Let's resume with kinematics. So we were doing summer 21 QP41. The question number now is 5. It says a particle moving in a straight line starts from rest at point A and comes instantaneously to rest at point B. The acceleration of the particle at time t seconds after leaving A is a meters per second square, where A expression is given. Find the value of t at point B. So this is the particle which starts from A, ends at B. The acceleration expression is given. It moves from rest at point A, so the velocity over here is 0 at time t is equals to 0, and at B the velocity again becomes 0. So it asks about what's the value of t at point B. Now for this we somehow have to get a velocity expression and put velocity equals 0 and find the required time. So let's integrate acceleration. So integrating acceleration would give me the velocity which equals 6t half plus 1 over 3 by 2 minus 2t square by 2 plus c. So this would become 4t 3 by 2 minus t square plus c. We are given that at time t is equal to 0 the velocity is 0, so c becomes 0, and the expression for velocity becomes v equals 4t 3 by 2 minus t square. So we need to find the time t at point B. So at point B the velocity is 0. Now what we need to do is put velocity equals 0. So this would become t square equals 4t 3 by 2, and this would become t2 minus 1.5 equals 4, t raised to the power half equals 4. Squaring both sides would give me t equals 16 seconds. So t equals 16 seconds is the answer for the time at point B. So in part B it says that find the distance traveled from A to the point at which the acceleration of the particle is again 0. So what we need to do is put acceleration equals 0, find the time t at which the acceleration is 0, and for that time we need to find the distance. So let's first find the t at which the acceleration is 0. So putting a equals to 0, 6t raised to the power half minus 2t, 2t equals 6, t raised to the power half would make up t1 minus half equals 3. So this would make up t raised to the power half equals 3, and squaring both sides makes t equals 9 seconds. So at t equals 9 seconds the acceleration is 0. Now it says to find the distance. Now in order to find the distance, what we need to do is integrate the velocity from 0 to 9 and solve it up to get the distance. So let's do it. The velocity expression is 4t 3 by 2 minus t square. So integral from 0 to 9 of 4t 3 by 2 minus t square, 4t 1.5 plus 1 is 2.5 by 2.5 minus t cube by 3, and the boundaries are from 0 to 9. Substitute 9 into this expression and you will get 145.8 minus 0 would give me 0. So the displacement would be, or the distance or the displacement would be 145.8 meters. So question number 7, summer 21, says that a particle P moving in a straight line starts from rest at point O and comes to rest 16 seconds later. At time t seconds after leaving O, the acceleration A of P is given by three expressions. It further says that there is no sudden change in the velocity at any instance. Find the value of t when the velocity of P is 55 meters per second. So let's check, where does the velocity reach 55 meters per second? We have to integrate them. So let's first write the initials. It says that it starts from particle P starts from rest at point O. Over here the velocity, initial velocity was 0 at time t is equals to 0, and at 16 t is equals to 16 seconds, it says that the velocity is again 0, and we need to find the velocity, the time when the velocity is 55. So let's first check the interval 0 to 2 seconds, which is 6 plus 40, for which the acceleration is, and see the velocity integral of A, which is the velocity in this case, is 0 to 2 6t plus 4t square by 2. This would make up 6t plus 2t square. Putting the values 0 to 2 would give us 12 plus 4 into 2 square is 4, which is 28 meters per second. So this is not the interval 0 to 2. Let's check the second interval. So the second interval is, now seeing the second interval, acceleration is equals to 14. We have velocity equals 14t. So that would become in the interval 2 to 4. So that would make up 14 multiplied by 4 minus 14 into 2. So this would be equal to 28. So that means that the velocity is still 28 over here. So the interval in which the value of P is 55 is surely in the third equation. So let's check the third. Let's first integrate the third expression. At t is equals to 16, velocity is 0, so we can find c as 0. Now put velocity as 55 and find the respective value of t. So the values of t are t equals 5 and t equals 11. The next part, it says to sketch the graph from 0 to 2. So it's a positive quadratic, so that would be something like this, and from 4 to 16 is a cup downwards curve, a cup downward quadratic, negative quadratic, the turning point at being 8,64. That's it for this video. Do like and subscribe my channel for more questions and more related videos. Thank you.